Hello everyone, welcome back to my channel. Today let's review a medium that I just solved on my own a couple minutes ago. I had originally misunderstood the question a bunch of times, but I reread it and I solved a similar question on my own and I realized what I did wrong. So the importance is just reading the question carefully. So here you're given an integer n and a perfectly straight street is represented by a line ranging from 0 to n minus 1, and you're given a matrix. Basically, this just means 0 is going to be the... So, this is a bit confusing, but basically, let's just make sure that you get 0 and 1, and 1 and 3, and 1 and 4. So, what we want to do is actually create a array of length n filled with zeros, go over lights, and so this is going to be the position, this is going to be the range. So let's call this position, and range is L0 and L1. And then let's call this the left bound and the right bound. So the left bound is going to be the max of 0 right here, and position minus range. And then the right bound is going to be the minimum of n minus 1, which is given to us. So minimum of n minus 1 and position plus range. Cool. So now let's print left bound and right bound. We want to make sure we get 0, 1, and 1 and 3. 0, 1, cool. 1, 3, and 1, 4. Okay. So basically, they said light this range up, which basically just means incrementing it by 1. It doesn't say it explicitly, but you really have to just play around with the test cases to figure it out. So now, if we want to increment a particular subarray by an amount, you do 1, 0, -1, and then you accumulate that because you get 1, 1, 0, right? 1 minus 1 is 0. That's where it stops. This is the subarray that's incremented by 1. So you do the -1 to the right of 1 where the subarray ends. So let's do result of left bounds plus equal to 1. And then, right, if there is no right bound, make sure there's a right bound. So if right bound plus 1 is less than length of result, then we can right bound plus 1 minus equal to 1. So we're doing this. And let's print result. Okay, so now what we want to do is accumulate this result. Let's print A. And now what they mean is basically, now you can basically take what you got here, the accumulated version, and then the requirement, and you just count how many elements in your accumulated version are bigger than or equal to the same index element in the requirement. So here you have 4 bigger than or equal to counts as well. So now you can just say answer is 0 because we want to return an integer. And then for I value in enumerate A, we're going through this. And if value is bigger than or equal to requirement of I, then answer plus equal to 1. And then at the end, we can just return answer. So there you go. Passes all test cases. Again, not the most efficient, but I did come up with this on my own. Did take a couple of tries because I misread, and there were some implications here, such as plus equal to 1 is the meaning of lighting up. They should probably specify that, but pretty happy either way. So hopefully this is intuitive. If you understand the line sweep algo, this isn't too hard. So thank you for watching and stay tuned for more.